All right, guys, so what we want to do is we want to take some of those properties of angle bisectors that we talked about earlier, and we want to be able to apply those in order to find the equation of an angle bisector. So let's go ahead and do that. The first thing we want to look at, we want to use are the ratios. And in particular, we're looking at the ratio of the adjacent sides. We're going to use that to help us figure out where this perpendicular bisector, or I'm sorry, this angle bisector is going to intersect at this point of intersection D. So we're looking at the ratio of adjacent sides, and in order to do that, we need side lengths. So first side length is up here. We've got from A to B. We're not moving any in the Y direction, which is nice. We're just going from 2 to 4, which tells me that AB is equal to 2. All right. The second one that we need to figure out here is AC. And AC is just the hypotenuse. If I drop this line down and create a right triangle here, we know that this side length is going to be 4. This height is going to be 3. And so therefore AC is going to be equal to the square root of 4 squared plus 3 squared. 16 and 9 is 25. AC is the square root of 25, or just 5. So nice easy lengths for us to start with here. So I've got a ratio of adjacent sides of 2 to 5. My adjacent sides, meaning the sides that are next to this angle bisector, that are next to the angle that is being bisected. Okay, so the next thing that we're going to talk about is really how do I locate the position of this point? Because if I want to write the equation of this angle bisector, I know that it passes through these 2 points, and once I have 2 points, I can write that equation by finding the slope and then putting it into point-slope form. So I need the location of D here, this point of intersection. Well, we talked about before, an angle bisector doesn't necessarily chop this in half. It would be nice if it did, because then we can just use the midpoint, but it doesn't. But what we are going to use is something that's pretty similar to the midpoint formula. Really what we're going to do is scale this. We're going to kind of scale the coordinates to match my ratio up here. So let me say that again. We're going to scale the coordinates, or scale the side here, so that it matches the ratio of my adjacent sides in order to find the coordinates of this point of intersection of my angle bisector through these opposite sides. Okay, so what we need to do essentially in order to scale these coordinates is look at the x first. So let's take a look at the x. You can see I've color-coded some of these. So what we're going to do is basically similar to the midpoint formula, but we know it's not a midpoint. It needs to be scaled according to this ratio up here. So that's what we're going to do. We're going to look at the x-coordinate first. When we look at the x-coordinates, we take our the length of our first side, and in this case it's AB, so that is 2. And we're going to multiply that side by our x1, or our first x-coordinate. So we're going to multiply the first length in our ratio by the x-coordinate x1. All right, so that's the first portion, or the first way that we're going to scale this, or the first part of our scaling. The second part is we need to take this other length, the 5, the length of AC, and we need to multiply that by our x2. So our second x-coordinate. All right, so we've got length of the first side in our ratio times our first x-coordinate, length of the second side in our ratio times the second x-coordinate, and that's going to give us the first portion of what we need. The second portion of this is we're not dividing by 2 like we usually do with the midpoint formula. In this case, because we want to scale it, we want to divide by the total length of the adjacent sides. Okay, so we found our lengths up here. Total length of the adjacent side is how we're going to scale this. So we're actually going to divide by whatever that total length is. And we know that our particular sides are 2 and 5. So we go through and divide by that total length of the adjacent side. So that's the first portion of it. That's our x coordinate. Again, it's similar to the midpoint formula, but because we're scaling it and not finding an average, we're going to multiply by the lengths of our sides and incorporate the coordinates, and then we're going to divide by the total length of the adjacent sides. We're going to do something really similar to the y. So we're going to take our first length in our adjacent side, and our y1, we used purple here. Here's y1. So I'm going to multiply that by 0 for our y1, and we're going to add that to the second length, 5, times our y2, which we have color-coded with red here, times y2. So our y2 was 3, I believe. Let me check that out and make sure. Yeah, our y2 is 3. And to finish this off, again, we're not dividing by 2 because we're not taking the average. We're scaling this, so we're going to take the total length of our adjacent sides. All right, so what we're going to look at here is just a little simplification. So 2 times 0 I know is 0, plus 5 times 2 is 10. So my x coordinate is actually at 10/7. My y coordinate for this intersection is going to be at, that's 15/7. So this is actually point D. This is the point of intersection of the angle bisector and opposite sides. All right, so we've scaled this so that it fits the ratio of our adjacent sides, and we use that in order to figure out what the coordinates of point D, or the point of intersection, was. So the last part of this, and that's really the toughest part, is figuring out this scaling. The last part of this is we've now got 2 points for our angle bisector, so use those 2 points. I know that angle bisector passes through 4, 3. That was point A up here. There's 4, 3. And then the other one is 10/7, comma 15/7. So 4, 3 and 10/7, comma 15/7. All right, so I should be able to find the equation of my angle bisector by going through, finding the slope, which I'll do right now. So y2 minus y1, so that's 15/7, and you're going to get some fractions in here. I'm going to go ahead and find a common denominator. I know that 3 is equal to 21/7. And 10/7 minus 4, but I know that 4 is equal to, what is that, 24/7. Nope, 28/7, sorry. So my slope then is going to be negative 6/7 over negative 18/7. Go through and simplify. We flip and multiply. And when you flip and multiply, your 7s are going to cancel out. I'll leave you to do the math on that. But you should end up with 1/3. So a nice easy slope. That's 1/3. And the other thing that we have 2 points that this thing passes through. So in order to write the equation of this angle bisector, a couple different ways. The easiest way, like we talked about a lot in class, is use the slope. We've got the point and a slope, so point slope form for this angle bisector is going to be y minus 3 equals 1/3 times x minus 4. And we are done. So just to give you a general idea of what this thing is going to be, it's going to have a slope of 1/3. It's increasing, so it's positive, which looks like our line is positive, or increasing from left to right. come down here. This guy right here is, that's going to give us, in slope-intercept form, is going to look like 4/3 minus plus 9/3. Negative 4/3 plus 9/3 is going to give us 5/3. So it's going to have a y-intercept of 1 1/3, which is going to be right around here. All right, so again, either form is fine. Point slope is fine. You can stop with that. The process, again, is this process right here is the most difficult part. But just remember, we are scaling so that it matches our ratio of adjacent sides. We're not taking, it doesn't pass through the midpoint, so we can't use that midpoint formula. We're going to scale those coordinates so that it matches the ratio.